Is the universe 26.7 billion years old? New discoveries challenge the Big Bang model. The foundations of the universe are shaking. For nearly a century, the Big Bang theory has stood as the dominant explanation for the origin of our universe. According to this model, the universe sprang into existence approximately 13.8 billion years ago from a singularity, a hot, dense point of infinite energy, and has been expanding ever since. This model is backed by substantial observational evidence: the cosmic microwave background radiation, CMB, the expanding universe observed through redshifted galaxies, and the abundance of light elements, such as hydrogen and helium. Yet, recent observations made by the James Webb Space Telescope, JWST, are challenging long-standing assumptions about how the universe formed and evolved. These observations have sparked what some scientists are calling a cosmological revolution, prompting experts to rethink not only how galaxies form, but when the universe began. Among the most shocking of these revelations is the potential recalculation of the universe's age from 13.8 billion years to possibly 26.7 billion years. James Webb unveils a universe that shouldn't exist. Launched in December 2021, the JWST was designed to peer deeper into space, and thus further back in time, than any telescope before it. What it found, however, was beyond surprising. In a time window stretching from just 200 million to 1 billion years after the supposed Big Bang, Webb discovered thousands of fully formed galaxies, many of which are disk-shaped, organized, and strikingly similar to modern spiral galaxies like our own Milky Way. A galaxy that breaks the rules, Source 2112. One galaxy in particular, Source 2112, has stunned astronomers. Detected as part of the Cosmic Evolution Early Release Science Survey, Source, this galaxy existed when the universe was just 1.5 billion years old, yet it already exhibits a stable, rotating disk structure, a feature thought to require several billion years of gradual development, shaped by the merger of smaller galaxies and the slow accretion of matter. The Milky Way, for example, took roughly 10 billion years to achieve its present form. But Source 2112 looks like a galactic twin, and it existed 9 billion years earlier than our galaxy reached the same level of complexity. This is not an isolated anomaly. The JWST's high-resolution infrared images have revealed 1,672 disk galaxies among the 3,956 galaxies discovered in a single deep-field image. These findings conflict with the conventional view that galaxies in the early universe should be small, irregular, and chaotic. The cosmic timeline problem. The existence of such well-structured galaxies at such an early epoch introduces a severe dilemma. If these galaxies evolved according to the rules we've used for decades, they would have had to begin forming before the Big Bang, a paradox that calls the entire timeline of the standard model of cosmology into question. Possible explanations. The Big Bang happened earlier than we thought, and the universe is older than 13.8 billion years. Galaxies formed much faster than current astrophysical models allow, requiring a turbocharged evolution mechanism. The Big Bang model is fundamentally flawed or incomplete, and the universe might be eternal or originated differently. One physicist, Professor Rajendra Gupta of the University of Ottawa, believes he has an explanation that fits the evidence, and it's as bold as it is controversial. Rajendra Gupta's revolutionary theory, a 26.7 billion year old universe. Gupta has been studying alternative models of cosmic expansion, and his recent work aims to resolve inconsistencies in current cosmological data, especially the so-called Hubble tension, the conflict between different measurements of the universe's expansion rate. In a 2023 study, Gupta presented a model that combines several groundbreaking ideas: a modified version of Einstein's general relativity, a dynamic and evolving form of dark energy, and a revival of Fritz Zwicky's tired light theory, which proposes that light loses energy and therefore shifts red as it travels through the universe, without the need for space itself to expand at a constant rate. Gupta's recalculations suggest that the universe could be 26.7 billion years old. In some scenarios, if tired light effects and other factors are fully accounted for, it could be as old as 42 billion years. Why the recalculation matters. If Gupta is correct, this extended timeline would provide ample room for galaxies like CERS 2112 to evolve naturally, solving the timeline problem without invoking unknown turbo-evolution processes or discarding the laws of physics. Moreover, it would challenge the need for some currently unproven constructs like dark energy and dark matter, both of which are vital to the Big Bang Theory's expansion model but remain undetected in laboratory settings. The Big Bang under fire. This isn't the first time scientists have raised concerns about the Big Bang model. Over the decades, some have criticized its heavy reliance on unobservable entities, like dark matter and inflation fields, and fine-tuned parameters to make the model fit observations. Critics argue that other theories, such as the steady-state model, plasma cosmology, or cyclic universes, may better explain the universe without requiring a singular starting point. However, the Big Bang model has endured largely because it successfully predicted the cosmic microwave background radiation, CMB, and elemental abundances. Yet now, even these pillars are under scrutiny. If the early universe wasn't expanding the way we thought, then the interpretations of the CMB and the role of early stars, population 3 stars, might also need revision. Dark matter and dark energy, still theoretical after decades. Despite decades of searching, we still haven't directly detected dark matter or dark energy, yet they account for 95% of the total mass energy content of the universe in the Big Bang model. Gupta and other alternative theorists suggest that the discrepancies in galactic movement and expansion can be explained by changes in physical laws over time or unknown properties of light and gravity, without needing these mysterious, invisible substances. If true, this would further erode the foundations of the Big Bang Theory and support a universe that behaves in radically different ways than we currently understand. A new cosmic paradigm? The implications of a 26.7 billion year old universe, or one even older, are enormous. Not only would it rewrite the timeline of cosmic evolution, but it would also reshape our understanding of the origin, structure, and fate of the cosmos. It could explain how massive, organized galaxies formed so early, why certain quasars and black holes appear to have existed too soon, and why our measurements of the universe's expansion don't align. However, such a paradigm shift won't come easily. The astrophysical community, while intrigued by these findings, remains cautious. Extraordinary claims require extraordinary evidence, and Gupta's theory, while compelling, has yet to achieve broad consensus. The beginning of a new scientific revolution. Science advances not just through the confirmation of theories, but through their constant testing and questioning. The discoveries made by the James Webb Space Telescope represent one of the most exciting frontiers in cosmology today. Whether they lead to a simple refinement of the Big Bang model or to an entirely new understanding of space and time, only time and further evidence will tell. So as we look up at the night sky, remember, we may be looking at a universe twice as old and twice as mysterious as we once thought.